Was Mars habitable 3 to 3.5 billion years ago? Scientists have long pondered this question, and recent discoveries suggest that yes, it could have been. The red planet had the right ingredients: water, energy sources, and essential minerals, to potentially support life. But modern Mars is a stark, frozen desert, a shadow of its potentially habitable past. So what happened? Could life have emerged during Mars' golden era? NASA's Perseverance rover aims to answer the next critical. The Perseverance rover, equipped with state-of-the-art instruments, is not merely joyriding across the Martian surface taking selfies. Its mission is ambitious: analyze soil samples, hunt for signs of ancient water, and search for evidence of life. The images and data sent back to Earth, however, are raising more questions than answers. Strange shapes and shadows emerge from the red dust, formations that defy easy explanations. While NASA maintains these are rocks shaped by natural processes, others argue they resemble artifacts, stirring theories of ancient civilizations. Mars isn't just a dead, dusty wasteland. Evidence points to ancient rivers, deltas, and minerals that require water to form. NASA has confirmed these discoveries but remains cautious about their implications. If Mars had water, could it have also harbored life? The agency's reluctance to leap to conclusions may be understandable. Scientific rigor demands caution. However, skeptics argue that NASA's guarded statements might mask a bigger revelation. Could there still be hidden water beneath the Martian surface, or even life forms surviving in extreme environments? One of the most intriguing discoveries on Mars involves methane. On Earth, methane is often a byproduct of biological activity, primarily microbial life. Curiosity and Perseverance have detected seasonal bursts of methane on Mars, but the source remains a mystery. NASA has suggested geological processes might be responsible. However, the seasonal variations in methane levels align with what might be expected from biological activity. Why, then, is NASA so tight-lipped? Some speculate the agency wants to avoid premature conclusions, while others believe they're holding back game-changing discoveries. The rover's cameras have captured countless images of rock formations resembling statues, structures, and even fossils. NASA's official stance attributes these shapes to pareidolia, the human tendency to see patterns where none exist. But skeptics argue that some formations look too precise to be mere coincidences. Could they be remnants of an ancient civilization? NASA's consistent geological explanations seem to sidestep these questions, leaving room for speculation. If these structures are artificial, what story do they tell about Mars' past? Adding to the mystery, certain rover images appear to show fossil-like shapes resembling sea creatures or plants. NASA has dismissed these as natural formations caused by wind erosion. But what if they're wrong? Could Mars' surface hide evidence of an ancient biosphere? The absence of a definitive answer keeps the debate alive. And while NASA emphasizes scientific caution, some wonder if they're waiting for absolute proof before announcing any findings that could reshape humanity's understanding of the cosmos. One of the more controversial theories about Mars involves the possibility of a nuclear catastrophe in its distant past. Certain isotope levels, such as xenon-129, have led some scientists to speculate about an ancient nuclear event. While mainstream science dismisses this idea, it continues to intrigue the public. If Mars once hosted a civilization advanced enough to cause its own destruction, the implications are staggering. Could this be a cautionary tale for Earth? As discussions of terraforming Mars gain traction, some theorists suggest NASA might already be testing technologies to manipulate the Martian environment. Officially, the agency focuses on scientific exploration. However, technologies developed for studying Mars, such as tools to extract oxygen from its atmosphere, could have dual purposes. Could early steps toward making Mars habitable for humans be happening under the guise of exploration? And if so, what does this mean for the future of humanity's interplanetary ambitions? The twin rovers Spirit and Opportunity, which landed on Mars in 2004, laid the groundwork for today's missions. Opportunity discovered hematite, a mineral that forms in water, and Spirit found silica, often associated with hot springs on Earth. These discoveries pointed to a Mars that was not only wet but possibly warm, creating conditions ideal for life. Yet, the excitement surrounding these findings seemed to fade quickly. Why didn't NASA push harder to investigate the possibility of ancient Martian life? Opportunity's discovery of Blueberry's tiny spherical pebbles formed in water was another groundbreaking moment. These formations indicated that liquid water once flowed through the Martian ground. Despite their significance, discussions about the blueberries often stopped short of addressing the bigger question: what lived here? NASA's reluctance to cross this line continues to fuel speculation. Landing in Gale Crater in 2012, the Curiosity rover revealed a Mars with a complex and dynamic history. It found ancient lake beds, streams, and clay, a material excellent at preserving organic matter. Even more tantalizingly, Curiosity discovered organic molecules, the building blocks of life, embedded in the Martian soil. While these molecules could have formed through non-biological processes, their presence suggests Mars might have supported life. Curiosity also detected seasonal methane variations, adding another layer to the mystery. The methane issue persists as one of the most compelling enigmas. Methane detected by Curiosity doesn't last long in the atmosphere, meaning something must be replenishing it. On Earth, that something is often life. The seasonal nature of these emissions hints at biological activity, yet NASA remains cautious. Are they withholding information, or do they genuinely not know the source? The Perseverance rover's exploration of Jezero Crater, an ancient lakebed, represents humanity's best chance yet to uncover signs of past life on Mars. By analyzing soil and rock samples, the rover aims to detect biosignatures, chemical markers that indicate the presence of life. If Perseverance finds definitive evidence, would NASA announce it immediately? Skeptics argue the agency might delay, carefully framing the narrative to avoid public panic or misinterpretation. Mars continues to surprise us with its hidden complexities. From whispers of terraforming to debates about ancient civilizations, the red planet remains an enigma. While NASA focuses on scientific caution, the public's curiosity grows. Every new discovery fuels speculation, pushing the boundaries of what we thought we knew about our celestial neighbor. As the rovers continue their tireless work, the story of Mars unfolds layer by layer. But the biggest questions remain unanswered. Was Mars once home to life? Could it still harbor microbial inhabitants? And if so, what does this mean for humanity's place in the universe? Whatever the truth, one thing is clear: Mars is far more than just a dusty red sphere. It's a world of mysteries waiting to be unraveled, and the next discovery might change everything we know about life.